Hi everyone, today we're going to be solving AQA GCSE Chemistry Higher Tier Paper 2. In this particular question paper, we're solving June 2021. This is a part 1 of the question paper, and in this particular video, we're going to be solving from question number 1 to question number 5. This question is about fuels and energy. Figure 1 shows the percentage of electricity generated in the UK between 2007 and 2017 using oil and solar energy. The percentage of electricity generated, and here are the years that are mentioned. Describe the changes in the percentage of electricity generated in the UK between 2007 and 17 using oil and using solar energy. We can use the data from the figure 1 in our answer. We can see from the graph that the use of oil has decreased by 0.8%. It decreases from 1.3% to 0.5% from 2007 to 2017. And then the use of solar has increased by 3.4% from 0% in 2007 to 3.4% in 2017. The use of oil increases from 2007 to 2009 and then it decreases. However, there is no change in oil use between 2013 and 2015. And there is no change in solar energy use between 2007 and 2009. However, the use of solar energy increases most between 2013 and 2015. Between 2007 and 2011, more oil was used, and between 2013 and 2017, more solar energy was used. Oil contains carbon and some sulfur. When oil is burned, the products of combustion may be released into the atmosphere. Explain the environmental effects of releasing these products of combustion into the atmosphere. Complete combustion of oil produces carbon dioxide gas, which is a greenhouse gas. A greenhouse gas increases the surface temperature of the earth, which leads to global warming and climate change. Fuel within the sulfur gets burned to produce sulfur dioxide, which then causes acid rain. It can damage the buildings and statues, and also it damages trees, aquatic animals, and then causes respiratory problems in humans. Incomplete combustion produces carbon monoxide, which is toxic, and produces carbon, which is soot. These are particulates which leads to global dimming and respiratory problems in humans. Suggest one reason why using solar energy is more sustainable way of generating electricity than burning oil. Solar energy is a renewable source of energy and oil is a finite source of energy. Solar energy may not be able to replace the generation of electricity from fossil fuels completely. Suggest two reasons why. In this answer, we're going to write that sunshine is very unreliable because in cloudy situation, we cannot get enough electricity generated from solar power. And then the second point will be there is an increased demand for energy which cannot be met using solar power, or apparently we can say that lack of space for putting the solar panels. This question is about alkanes. Table 1 shows the information about some alkanes. We can see the number of carbon atoms in alkyl molecule and the boiling point of the alkane increases accordingly. Plot the data in the table 1 on figure 2. Predict the boiling point of X of the alkane with 7 carbon atoms in a molecule. To do this particular answer, we'll have to extrapolate. Figure 2 is not suitable to show the boiling point of the alkane with 3 carbon atoms in a molecule. Suggest one reason why. The boiling point of a 3 carbon containing alkane will be lower than 0 degrees Celsius, and figure 2 doesn't have that space. What is the state at 20 degrees Celsius of the alkane with 4 carbon atoms in a molecule? Since the boiling temperature for the 4 carbon atom is 0 degrees Celsius, so it's going to be a gas. Table 1 is repeated below. The alkane with 9 carbon atoms in a molecule is called nonane. Complete the formula of nonane. So since it is an alkane, so the general formula is CnH2n plus 2. So it will be C9H20. Nonane will condense lower in a fractionating column during fractional distillation than the other alkanes in table 1. Explain why. We should refer to the temperature gradient in the fractionating column. So basically, nonane has a higher boiling point, so it condenses, whereas where the column has a higher temperature. And since the column has a higher temperature, lower, so it will condense lower in the fractionating column. This question is about paper chromatography. The food coloring contains a dye. Plan an investigation to determine the RF for the dye in this food coloring. The formula for the RF is given: distance moved by the substance divided by distance moved by solvent. Our plan should include a beaker, a solvent, and a chromatography paper. So first of all, we'll take a chromatography paper and draw a pencil start line on the paper. Then we're gonna place the spot of the food coloring on the start line. Then we're going to use water as a solvent because this is a food coloring, so water is the solvent. Then we're gonna place the solvent in the beaker and place the chromatography paper in such a way so that the chromatography paper is in solvent but the solvent is below the start line. And then we're going to put a lid on top of it and wait for the solvent to travel up the chromatography paper until it reaches near the top but not exactly to the top. Then we will mark the solvent front up until the part where the solvent has traveled, and then we will dry the chromatography paper. Then we will take the following measurements. Measure the distance between start line and the center of the spot that we have reached, and we will also measure between the start line and the solvent front. Then we will use both of these values to calculate the RF value. The students investigated a dye in a food coloring using paper chromatography. Each student did the investigation differently. The RF values they determined for the same dye were different. How did the students' investigation differ? Using different length of paper or different period of time or different size of beaker that cannot affect RF value. However, if a different solvent is used, then the RF value differs because different solvent have different attraction towards the solute that they are trying to carry. Paper chromatography involves a stationary phase. What is the stationary phase in paper chromatography? So in a paper chromatography, the solvent is the mobile phase and the paper is the stationary phase. This question is about polyethylene and polyesters. Polyethylene is produced from ethene, and figure 3 shows the displayed formula equation for the reaction. So we can see CC double bond, and turning into polymer, polyethylene will have CC single bond, and we will re-establish the bond between hydrogens. Polyethylene is a thermosoftening polymer. Suggest why polyethylene is easier to recycle than thermostatic polymers. Thermosoftening polymers such as polyethylene melts, so we can melt it to reshape it into new products. Ethene produces different forms of polyethylene. How can different forms of polyethylene be produced from ethene? If we use different reaction conditions, then different forms of polyethylene can be produced. Two different forms of polyethylene are high density polyethylene HDPE and low density polyethylene LDPE. Figure 4 represents part of the structures of HDPE and LDPE. So we can see the structure of HDPE and we can see the structure of LDPE. In HDPE, we can see they're regularly arranged, and in LDPE, we can see they're loosely arranged from different corners. Explain why HDPE has a higher density than LDPE. So our answer would be, in HDPE, polymer chains, molecules are close together, so there are more atoms per unit volume, which gives it greater density. Figure 5 shows the three monomers A, B, C. Monomer A can react with monomer B and monomers with monomer C to produce polyester. We can see monomer A is a dialcohol, whereas monomer B is a dicarboxylic acid because of the COOH. Monomer C is a diacid chloride, which is similar to dicarboxylic acid but more reactive. Draw a circle on figure 5 around an alcohol functional group. Complete table 2 to show the formula of the small molecule produced when monomer A reacts with monomer B. When monomer A reacts with monomer B, monomer A loses the hydrogen and monomer B loses the OH. The H and the OH together produces H2O. When monomer A reacts with monomer C, monomer A loses the hydrogen and monomer C loses the carbon, the chlorine. So it produces HCl. This question is about fertilizers. Some fertilizers are described as NPK fertilizers because they contain 3 elements needed for healthy plant growth. Which 2 compounds contain 2 of these elements? So NPK, N stands for nitrogen, P stands for phosphorus, and K stands for potassium. So ammonium compound consists of nitrogen. Nitrate also contains nitrogen. So ammonium phosphate consists of nitrogen and phosphorus. Calcium chloride does not contain any one of this component. Calcium phosphate has has phosphorus, however does not have nitrogen or potassium. Potassium chloride has potassium but does not have nitrogen or phosphorus. And potassium nitrate contains potassium and nitrogen. Rocks containing calcium phosphate are treated with acid to produce soluble salts that can be used as fertilizer. Name the soluble salt produced when calcium phosphate reacts with nitric acid and phosphoric acid. So if the calcium phosphate reacts with nitric acid, it will produce calcium nitrate, and when calcium phosphate reacts with phosphoric acid, it will produce calcium dihydrogen phosphate or calcium triple superphosphate. Ammonium sulfate is a compound in fertilizer. Ammonium sulfate can be used using an industrial process or in the laboratory. In the industrial process, the following steps are used. React streams of ammonia solution and sulfuric acid together. Evaporate the water by passing the solution down a warm column. Collect dry crystals continuously at the bottom of the column. In the laboratory, the following steps are used. React ammonia solution with sulfuric acid in a conical flask. Evaporate water from the solution until crystals start to form. Leave to cool and crystallize together. Crystallize further. Separate the crystals using filtration. Dry the crystals between pieces of filter paper. Evaluate the two methods for producing large mass of ammonium sulfate. The industrial process is a larger scale process and it is continuous. Thereby, it will produce the large amount of ammonium sulfate faster. The industrial process is quicker and also reduces cost and energy. The industrial process does not need to be repeated in terms of the crystallization and filtration several times. So guys, that's all for question number 5. And guys, see you in the next video. In the next video, we're going to be solving from question number 6 to question number 10. Thank you for watching. See you in the next video. Bye-bye.